The factoring method works well for many quadratic equations. However, as I mentioned at the end of the last video, not for all of them. If I have a quadratic equation that starts off with a 1 in front of the x squared, I tend to try to solve it by factoring. Having a coefficient of 1 in front of the x squared makes it a little easier to solve. What I advise students is that if you can solve a quadratic equation quickly by factoring after a few moments of looking at it, to do it that way. Otherwise, you might want to solve the equation by using the quadratic formula, which is another way of solving quadratic equations. The quadratic formula was developed by mathematicians thousands of years ago and is another way to solve a quadratic equation for x. The formula is x is always going to be equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Let me explain how this works. In the first video of this module, I had mentioned to you that the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. In order to use the quadratic formula, you will need to determine what a, b, and c are equal to in the equation that you are dealing with. So, let's say that we were dealing with the equation 4x squared subtract 8x subtract 5 is equal to 0. If I were doing that and I wanted to use the quadratic formula, the very first thing that I would do is I would identify what my a is equal to, what my b is equal to, and what my c is equal to. The a is whatever number comes before the x squared. So in this case, my a is equal to 4. The b is whatever comes right before the x. And notice that's a negative 8 because the formula says add bx and this says subtract 8x. So that's a negative 8. The c is a negative 5 for that same reason. So if I were going to do this particular problem by the quadratic formula, the very first thing I do is identify what those three different letters stand for. Then all I'm going to do is put those in and I'm going to work on solving that. I want to know first of all it says the opposite of b. b is equal to a negative 8. So I want the opposite of that. So I'm going to have x is equal to 8 plus or minus the square root of b squared. b is equal to negative 8, so b squared is 64. Subtract 4 times a is equal to 4, times c is equal to a negative 5, all over 2a, and since a is equal to 4, I have a denominator of 8. Then, at this particular point, I'm just going to go through and I am going to solve this. I have x is equal to 8 plus or minus the square root of, and now I want to figure out what it's equal to underneath the square root. So I have 64 subtract, and then I'm going to figure out the 4 times negative 5. 4 times 4 is 16 times negative 5 gives me negative 80, and it is all over 8. Following my dear Aunt Sally rules, I'm then going to figure out what it is equal to underneath the square root. 64 subtract negative 80 is 144. So I have 8 plus or minus the square root of 144 over 8. And as I continue that, I get 8 plus or minus the square root of 144 is 12 all over 8. Now remember, it's possible to have two different answers here, and that's why I have the add or subtract. If it is 8 plus 12, 8 plus 12 is 28ths. And if I take 28ths and if I reduce it to lower terms, I get 5 halves. If it is 8 subtract 12, 8 subtract 12 is a negative 4. I get negative 4/8, and negative 4/8 is equal to a negative 1/2. So I have two different answers here. I have 5/2 and negative 1/2 for the two different answers that x could be. Here's another example. If you feel comfortable doing it on your own, you might want to turn this off and go through and do it on your own, and then turn this back on again and watch me. But I will go through this now. I have 2x squared subtract 3x subtract 9 is equal to 0. The very first thing, once again, I'm going to do is I'm going to identify what my a is, what my b is, and what my c is. A in this particular case is 2, b is a negative 3, and c is a negative 9. So now I'm going to just put all those values into the formula. I get x is equal to, I want the opposite of b. b is equal to a negative 3, so the opposite of that is 3, plus or minus the square root of b squared. b is negative 3, so negative 3 squared is 9, minus 4, times a is 2, times c is negative 9, and it's all over 2a, and since a is equal to 2, it would all be over 4. Then I'm going to go through and just work on simplifying this. I have 3 plus or minus, and once again I'm going to go through and I'm going to figure out what I have underneath the square root. 4 times 2 is 8. 8 times a negative 9 is a negative 72. So I have 9 subtract negative 72 all over 4. Then as I go through, x is equal to 3 plus or minus the square 9 subtract negative 72 gives me 81 all over 4, and then I have 3 plus or minus 9 over 4, and then I'm just going to figure out what this is. If it's 3 plus 9, then I get 12 over 4, which is equal to 3. If it's 3 subtract 9, then I get a negative 6/4, which I might want to leave like that, or I could say that it's the same thing as a negative 3/2. So I have two different possible answers for this quadratic equation. X is either equal to 3 or x is equal to a negative 3/2. Do you remember one of my earlier videos that I had mentioned that when you do quadratic equations, there are either two answers, one answer, or perhaps no answers? And I had also mentioned that there's an easy way to figure that out. Let me talk about that a little bit more. Once again, when we have the quadratic formula, x is equal to the opposite of b plus or minus b, the square root of b squared minus 4ac all over 2a, there is a particular part of this that's called the discriminant. This part of the quadratic equation is called the discriminant because it helps you decide how many different values there are as far as the answer goes. And let me talk about it a little bit by doing this particular quadratic equation. In this particular quadratic equation, if I wanted to identify my a, my b, and my c, my a is equal to 1 because there's an understood 1 in front of the x squared. My b is equal to a negative 5, and my c is equal to 9. So I'm going to go through and I'm going to solve this by going through and putting all that information into the formula. If b is equal to a negative 5, the opposite of that would be 5 plus or minus b squared, which would be 25, subtract 4 times a, which is 1, times c, which is 9, all over 2a, and a is equal to 1, so it's just all over 2. As I go through now and continue to solve this, notice that I get 5 plus or minus, and then when I figure out what it is equal to underneath the square root, I get 25 subtract 36 all over 2. As I continue to work on this then, I get x is equal to 5 plus or minus 25 subtract 36 is a negative 11 over 2. Well, certainly when you have the square root of a negative 11, the square root of a negative 11 is not possible. So we say there is no solution for this. It's much more difficult to figure out that there's no solution by factoring, but it's easy to do this when you use the quadratic formula, because if you get a negative value underneath the square root, you know automatically that there's no solution because that's not possible. So that tells you that there are no values at all that will work for that particular equation. Let's continue to talk about this discriminant part with another equation. I have x squared plus 6x plus 9 is equal to 0. So in this particular case, a is equal to 1, b is equal to 6, and my c is equal to 9. When I go through and do this, I'm going to have x is equal to the opposite of b, so that's negative 6, plus or minus the square root of b squared, which would be 36, subtract 4 times a, which is 1, multiplied by 9, all over 2a, which would be equal to 2. Notice in this particular case, as I go through and figure out what it is equal to underneath the square root, once again this is known as the discriminant, I get 36 subtract 36 all over that 2. And since I get 36 subtract 36, that's equal to 0. So what I have is x is equal to negative 6 plus or minus the square root of 0 all over 2. Because this is equal to 0, it doesn't matter if I add or subtract, I'm going to be getting the same thing. Negative 6 over 2 gives me negative 3. So the answer to this is x is equal to negative 3, but I only have one solution for it. So before we finish this video, let me summarize the importance of this discriminant. If underneath the square root, which is known once again as the discriminant, if it ends up being a positive number, then I am going to have two different possible answers. If it ends up being equal to 0 underneath the discriminant, then I'm just going to have one possible answer. If it ends up being a negative number underneath the discriminant, then I am not going to have any possible answers whatsoever. The discriminant part of the quadratic formula will always tell me how many possible solutions I will have, either 2, 1, or 0. Being able to solve quadratic equations, either by factoring or by using the quadratic formula, becomes very important when doing applied problems, which I will talk about in the next video. I have all sorts of problems to practice this skill that you can access in this module. As always, please be sure to ask me for extra help as well.